each one of those because we're going to come back to each one individually and compare it to what science says. This crazy curve is nothing but I want to illustrate a point, and we'll get heavily into it. Cosmic time, or time across the universe, is measured by cosmic background radiation, the frequency and the temperature of that. Cosmic background radiation to a scientist is nothing but, if you will, the echo of Big Bang. If you assume that Big Bang or the initial explosion occurred, then there would be, should be, and indeed is, radiation that still exists throughout the universe that represents that radiation, if you will, of whether it's the sound or whether it is the nuclear radiation that we're talking about. I'm going to go forward for a minute, and then I'll come back to this. The cosmic background radiation is served as the frequency of the frequency of that radiation is the clock of the cosmos. Now, just a little diversion, which I covered the last time at the last 2 minutes, but some folks say we lost the sound and they asked me to repeat it. But a little personal experience with cosmic background radiation. Scientists had proposed and indeed claimed for at least 50 years that indeed, if Big Bang, if you will, did occur, then we should be able to detect that radiation throughout the universe. That has been sought after, or had been, for almost 50 years. While I don't know that anybody's ever accused me of being smart, so I've been blessed in two ways. One is nobody ever accused me of that, and number two, I never had to then act like I was smart. But I have been privileged over my career to work with some very smart people. One of those was the duration that I had at Bell Labs. I had the chance to work there with, not on his particular project, I was on a different world in Bell Labs, but there were two guys there, Bob Wilson and Roger Penzias, who were looking and listening for sounds from deep space. They were listening with an antenna that's, if you think of the little dish on your house for satellite TV, stretch that to about a 5-story building. And Bob's antenna was dish looking like that, but about 5 stories high. He was listening for noise, or if you will, communication from outer space. What Robert or Bob found out was no matter what direction he turned his antenna, he got a steady beeping sound, or noise, he claimed. Now, Bob was not looking for cosmic background radiation. That was not what his project was about. So Bob and Roger thought that that noise was coming from pigeon poop on their antenna. So they spent several days cleaning the antenna. Well, the noise didn't go away. And again, any direction in which they pointed the antenna, they got the same background noise. It took them several months and some help from some other people to decide, guess what? They have discovered or detected cosmic background radiation. The two of them later received the Nobel Prize in Physics. We used to kid Bob by being the only person we knew who won a Nobel Prize in Physics by studying pigeon poop. I guess the fun was that if you will, the CBR's background radiation follows, as I showed you in the previous slide, for you mathematicians, simply it's called a decaying exponential curve. We're not going to spend a whole lot of time on the mathematics. That's not the point of the presentation. But the point of the presentation is that if you take the frequency and or the temperature of the cosmic background radiation and plot it from the assumed occurrence approximately 16 billion years ago, and if you plot that as a function of Genesis days, In other words, the 24-hour day that we're used to, of day 1, day 2, day 3, and day 4. That's what that curve was about. The exponent of that curve from mathematics is based on the half-time, the half-life, or the time, if you will, half-time, of that radiation. All radiation follows that decaying exponential curve. And for instance, carbon dating is based on using the half-life period, which means how long does it take for that radiation to decrease to 1/2 of its previous value. That's called half-life. Okay, on the curve that I showed you earlier, what I did, it's a little more complicated than that, but what I showed you was, and I'll try to go back to that. Hang on just a second. If you look at the vertical axis, what I have plotted is really a surrogate for the frequency and the temperature of cosmic background radiation. And I have put basically on the vertical axis the 15.75 billion years ago. That would be the amount or the value of the temperature and or the frequency. Half of that is the 7.75. In other words, that's the period it took to decay to 1/2 of its value. I have chosen that as day 1 of cosmic time. Day 2 being the time it took to decay to 1/2 of the value of 7.75 or to 3.75. Day 3 would be the time that occurred between it decaying from 3.75 to half of that, and so forth, as you'll see there. Now what you will see is on the vertical axis on the left are 6 what I call cosmic days, or time across the universe, plotted as a function of Genesis days. What you'll notice is that by day 6, which is basically the time of Adam, and we're going to talk about that later, cosmic time had pretty well approached Earth time, if you will, or the time of Adam. So that by end of day 6, the clock of the cosmos pretty well agreed with the clock at that time would have been the planet Earth. And that's what that curve is showing. 2 or 3 slides before, I showed you a summary of each of day 1, 2, 3, 4, 5, and 6 according to Genesis. Here's, in this slide, what I'm saying is let's take the first cosmic day, the first half period, which is 15.75 to 7.75 during those billion, or roughly 7 billion years, and say, what does science say occurred during those roughly 7 billion years? What you have listed on this slide is for each of what I have called the cosmic days. I have listed beside it what science says occurred during that period of a few billion years, okay? Not going to read each one of them because we're, again, going to go into these in the next few slides where I'm going to compare biblical day 1 to cosmic day 1. So let's get to that. I think I've already said this, but prior to Adam, the Genesis clock, or Earth clock, if you will, and the cosmic clock, that's time relative to local gravity and motion according to Einstein's 2 theories of relativity, were calibrated in 2 different reference frames. And that's what physics tells us, and it's what common sense would tell us, because gravity and time, speed, affects time, the passage of time, if you're in a different reference frame, i.e. a different gravitational field or different speeds approaching the speed of light, then time travels differently. The cosmic clock is measured by the frequency and temperature of the cosmic background radiation. And by the way, before Bob and Roger found cosmic background radiation, scientists had calculated that the temperature of CBR should be approximately 3 degrees centigrade. What Bob measured was 2.73 degrees. And remember, cosmologists had calculated that based on a lot of assumptions. For instance, what's the real age, if you will, of the universe? Now, a lot of people have asked, why is there a 2 billion year difference between the estimates of the age of the universe? Scientists say it's somewhere between 14 and 16 billion. The question is, that's a pretty big window. Why so large? Well, primarily because to estimate or to calculate the age of the universe, number one, there is some guessing, but it's educated guessing. But also, it depends very much on some basic assumptions that you make about the universe. One of which is, what's the shape of the universe? Einstein spent a lot of his time, and a lot of astrophysicists have lately, trying to determine what is the shape of the universe. Current thinking is it's kind of shaped like a saddle, if you will, a saddle on a horse. Therefore, that shape determines one particular age. But again, even that interval of 2 billion years, please understand that to demand any more accuracy is like measuring something with a micrometer, mark it with chalk, and cut it with an axe. You're trying to imply accuracy that just is not there with current measurement techniques. So again, the 2 billion years in between there is pretty reasonable, and scientists call it's in the reasonable era of measurement. So what is the time of Adam? Well, what I did here was take the references in Genesis that are there and trace the line of Seth from Adam. And according to Genesis, Adam's first son was born when Adam was 130 years old, Seth 105 when his first was born, and so forth, down the line to Noah. So according to that, the time between Adam and Noah, or the flood, I'm sorry, not just when Noah was born, is approximately 1,656 years to the flood. Now we know, scientists estimate, or they think they know pretty well when the flood occurred, and that was roughly 4,114 years ago. So if you add the 4,114 years ago to the flood, which at that time was the 1,656 years, you get the time of Adam was approximately 5,770 years ago. So that's the time we were dealing with when the cosmological clock began to merge because of the decrease in radiation. I want to regress a little bit and look at the relativity of time. And the only thing I'm going to do here with that stupid equation that you see there, don't get scared of it. We're going to do a little third grade arithmetic is all. But the universe, St. Augustine, the first statement there comes directly from St. Augustine, and that is, the universe was created with time, not in time. Time did not exist. Neither matter nor space nor time existed until creation. This time differs with each local gravity, in other words, where you are in terms of what planet or what galaxy you're in, and it also differs with the speed of motion. Gravity is Einstein's general theory of relativity, which he didn't come out with, I believe, is 1912. The special theory of relativity was 1903, I believe, or roughly in that time. But special relativity dealt with time is relative to the speed at which an observer is traveling. That time is not absolute. Again, time basically, as you approach the speed of light in movement, what Einstein shows that you are going to trade space for time. The space you occupy decreases and time passes more slowly. So that's why he then came up with, where we normally think of 3 dimensions, it's really space-time dimension, 4 dimensions, because time and space interchange when you're approaching anything close to the speed of light. Let's take this dumb little equation here, if I can get the pointer. I just want to talk about, well, let me just define. The big T here is nothing but elapsed time of something that is traveling close to or approaching the speed of light. The little t is elapsed time for the person who is still, who is not moving anywhere close. And if you look at the little mathematics there, pay attention to the little ratio of v divided by c. V is nothing but the velocity or the speed that big T over there is traveling, the thing that is moving. C is the speed of light. It's the common constant that's recognized as the speed of light. What happens when V, the velocity that something is traveling, equals C? That ratio, V divided by C, is simply 1. Well, if you subtract it from 1, what do you get? 0. If you multiply 0 times little t, the elapsed time for the stationary thing, what do you get for the elapsed time of the things that's traveling close to the speed of light? You get 0. In other words, time stands still, okay, if you are traveling at the speed of light. The closer you get to the speed of light, the closer that V over C ratio gets to 1, meaning you're approaching 0 or time really slows down. Let's do just a calculation. Let's suppose you're using that same dumb little formula. Einstein figured it out. If you could travel at 99% of the speed of light to the center of our galaxy, not our solar system, our galaxy, and then return. So if you make a round trip to the center of our galaxy and return, the time, remember you're traveling at 99% of the speed of light, the time as measured by your watch or in your time frame would be just a few months. The person who remained on Earth, basically stationary or moving but nowhere near the speed of light, would have aged 30,000 years. Okay, so that's a significant example, if you will, of the difference that speed makes. Okay, so we all know that Einstein never did an experiment in his life. He figured everything out mathematically. So one might ask, is there any real evidence, physical evidence, that that little formula we looked at really is true? Well, there is, once we got the ability to measure it. And by the way, Einstein's theories are the only scientific theories that when we have developed the capacity to measure and test them, have shown to be 100% correct. Now, this little dude figured it out by math. He never, again, he was not a scientist in the sense of doing experiments. Okay, we do know, scientists know and can measure, we do know that millions, in fact hundreds of millions, of the subatomic particle mu mesons strike Earth's atmosphere every second. Now they're traveling at the speed of light. Therefore, it should take them 200 microseconds to travel the 60 kilometers to Earth's surface. In other words, traveling at the speed of light, it should take you 200 microseconds to reach Earth through our atmosphere. Now these mesons, depending on how you hear the pronunciation, they have a half-life of 1.5 microseconds. In other words, 50% of them are going to decay, disappear, in the first 1.5 microseconds. Now remember, we said it should take them 200 microseconds to transit the depth of the Earth's atmosphere. That means that less than 1 out of 10 with 34 zeros after it, only one of them should reach Earth. Well, measurements show that actually about 1 in 8 actually reach the Earth. That means for them, only 4.5 microseconds have elapsed in their time frame when they are traveling at the speed of light and traveling in terms of traveling the 60 kilometers to Earth's surface. So that's an actual measurement that shows here are particles traveling at the speed of light. It should take them, in terms of the way we measure time stationary on Earth, It should take them 200 microseconds, but it only takes them 3 half-lives, or 4.5 microseconds. Okay, so once again, Einstein was right. Guess what? Observed elapsed time in anything then, as Einstein's general relativity and special relativity showed, depends upon two things. General relativity says time depends on the gravity system you're in, whether you're on the Earth or the Moon, or also how fast you're traveling. Prior to Adam, the reference frame for time, cosmic time, was the entire universe. It was not the Earth. By the time of Adam, biblical time based on Earth, was or 24 hours a day. Cosmic time was based on time and also temperature across the cosmos. Both gravity and motion, meaning movement, differed in the universe where Earth was being created than it did in other parts of the universe. Earth time is measured in 24-hour days, 24 hours, remember, because the next slide I'm going to talk about that, even though Earth was created on day 3. Cosmological time is measured by the cosmic background radiation frequency, or temperature. We're going to now get into a day-by-day comparison of what the Bible says happened in Genesis day 1, 2, 3, 4, 5, and 6, and what science says in what I termed, and scientists have termed, cosmological time. Remember, the 6 successive half-lives of radiation. Day 1, Genesis 1 through 5 says the creation of the universe, the universe was created, obviously. Light separates from dark is what happened on day 1. Well, on Genesis day 1, what does science say happened in cosmological day 1? In other words, when the CBR was decaying from roughly 15.75 to 7.5, its first half-life. Well, here's what it says. Big Bang marks the creation of the universe by saying that light literally breaks free. It broke free because, we'll get to this later, but after Big Bang, the temperature of the universe was trillions of degrees, extremely hot. It was so hot that even the basic subatomic particles called quarks could not form. The atmosphere is not the correct term, but the environment of the then very small universe was what we refer to as plasma. It was neither liquid, solid, nor gas. It was a plasma. It was simply a very thick and concentrated collection of charged subatomic particles. But the universe was so hot they could not even combine chemically. What had happened was that after Big Bang, after a few million years, few billion actually, the universe began to cool, and it cooled down enough so that those elementary particles could combine and form quarks and then later hydrogen atoms, and we're going to look at that. God spoke to the emerging universe in the language that the 4 natural forces of the universe would understand. I had a slide in here that went through each of those, but it's kind of boring. But anyway, just take for granted, if you will, science has identified throughout the universe there are only 4 natural forces. One is the electromagnetic force. There's a strong nuclear force, the weak nuclear force, which is radiation, and gravity. Those are the only 4 forces that exist in the universe naturally. But God spoke to them, and we'll see in the language we use is mathematics. But he spoke to Moses in handing down Genesis in a language that Moses would understand. Just envision for a minute if God had said, okay, Moses, go sit on the rock over there. I want to explain creation to you, because you're going to have to write this down for future generations, because I want you humans to know. So Moses sits down and God said, okay, early on there was nothing. What we now call the universe was a pure vacuum. But soon there started rumblings in this vacuum, and energy appeared. There then was one heck of a humongous explosion. You later, Moses, are going to refer to it as Big Bang. But because of the heat of that radiation, none of the primary subatomic particles called quarks and strings could combine. And about that time, God would look at Moses and say, Moses, wake up. You know, are you asleep or what's going on? You need to know this. And Moses said, well, you talked about something called quarky confinement or something, which is what occurred, by the way, when the universe cooled. What does that mean? And God would say, oh no, Moses, just sit down a minute. Let me start over. So then God said, in the beginning, I created the heavens and the earth, and so forth. The rest is in Genesis. So again, Moses, remember, was no physicist, nor did science even exist. Remember, science didn't even start as a discipline until the 1600s with Galileo. So the whole concept of studying science, didn't even know what science was. Here's what God said in terms of electromagnetic radiation when he spoke to the universe. These are the, I'm sure you want to memorize all these and write them on your wall or something. This is nothing but Maxwell's equations describing electromagnetic energy. Don't get hung up on it. But the point was, this is what God said to the universe to create electromagnetic radiation. Now this is, if you see how converted some astrophysicists can be, here's the astrophysics equation of the whole universe. Now I know you're dying to know what it means, but I'm not going to tell you. If you have any questions, ask Bob May when you see him. He'll explain it to you, okay? But it's how convoluted we've become with mathematics. Our goal in physics is to discover the natural laws. And by the way, there's 6 of those, the natural laws. Not the natural forces. Remember, there are 4 natural forces. But what we've tried, or what physics is all about, is trying to discover what are the natural laws, and there's 6 of them. The first, as I said on the slide, was simply the law that governs electromagnetic radiation. Now let's go back. I had regressed a little, but we went to day 1, Genesis and cosmological, and we showed that there was almost a one-to-one correspondence to what Genesis day 1 said happened and what scientists say happened in cosmological day 1, which is the first 7.5 billion years. Let's look at day 2. In the Bible, in Genesis 6 through 8, it says it goes about of the heavenly firmament forms. Well, what does science say occurred in cosmological day 2? Okay, remember, from roughly 7.75 billion to half of that, Bob, you can do the math, whatever half of 7.75 is. But what I showed you on the previous. Well, again, Genesis says the heavenly firmament forms. Science says that the disk of the Milky Way forms, the sun, a main sequence star, forms. Again, pretty close. Well, here, even God can have a bad hair day. Day 2 is the only day of the 6 days of creation in Genesis that when God finished, he did not say, and it was good. He didn't say anything. It was only after day 3 that God was satisfied with what happened on day 2 and day 3. All the other 5 days, when God finished, he said, paraphrasing, but this is good. I did good, so, okay. Let's look at day 3. In Genesis 9 through 13, it says, on the 3rd day of Genesis, the oceans and dry land appear. The first life, plants, appear. The Kabbalah states this marked only the start of plant life, which then developed during the following days. A little bit about Kabbalah. Let me regress. And I realize, by the way, for some of you scholars, there are two additional different spellings of Kabbalah. It's spelled with two B's and one L and two B's and two L's. But the Kabbalah is the collection of wisdom. It's kind of the unwritten commentary, Hebrew commentary on what the Bible says. The Old Testament, excuse me. There is no book called the Kabbalah. It's the collection of wisdom, okay? Now, I do have a set of books Grace bought me that's, 24 volumes, I believe, Grace, that's called the Zohar. If you want your little brain to get torqued over, start reading that. It's weird stuff. But it was written 1,000 years ago, and it's a commentary on particularly Genesis, but on the whole Old Testament. Okay, day 3, book says ocean and dry lands appear. I've already said that the first slide. What does science say on cosmic day 3? The earth had cooled and liquid water appeared 3.8 billion years ago, followed by the first forms of life, bacteria and photosynthetic algae. Compare the two again, okay? What does Genesis day 3 say, and what does astrophysics say happened in the universe? Let's look at day 4. Genesis, the biblical day 4 says the sun, the moon, and the stars become visible in the heavens. That's Genesis 1, 14 through 19. What does science say happened in day 4 of the cosmic time frame? It says the Earth's atmosphere became transparent, i.e. you could see light coming through it. Okay? Photosynthesis produces oxygen-rich atmosphere. What about day 5? The Bible says on day 5, the first animal life swarms abundantly in the waters, followed by reptiles and winged animals. What does science say occurred in day 5 of cosmic time? Science says the first multicellular animals appeared. The waters swarm with animal life, having the basic body plans of all future animals. Winged insects appear. Almost identical to what Genesis says. On day 6, what does the Bible say occurred? Land animals, mammals, humankind appear. What does science say? On day 6 of the cosmic calendar, a massive extinction destroyed over 90% of life. God hit the reset button. Land is repopulated, hominids, and then humans appear, or man appears on day 6. Okay. Let's do an alternative check of time clocks compared to Genesis. According to the exponential decay and function of that radiation, from Big Bang, which we thought was, the echo of the explosion. By the way, let me regress a little bit. I think I forgot to say this. The main reason that Robert Wilson, Bob, and Penzias got the Nobel Prize was not so much that they actually detected Big Bang, but scientists have accepted Big Bang as proof, have accepted cosmic background radiation, the detection of it, as proof that Big Bang occurred. Before we assumed, we meaning scientists, assumed it had occurred, but we had no proof. So when Bob and Roger discovered cosmic background radiation, scientists have accepted that as proof that Big Bang did indeed occur in approximately 14 to 16 billion years ago. Now let's take that. We know, or scientists, I don't. Scientists have calculated pretty accurately within that margin of error what the strength of the Big Bang, that radiation, was when it occurred, and what it should be 16 billion years later. Okay? They have calculated that by the time of Adam in Earth time, the strength of that radiation, i.e. the temperature, should have decreased by a factor of 1 million million. In other words, the strength had decayed and the temperature so that it was 1/1,000,000th of a millionth of what it was at Big Bang. So let's take that 16 billion years of cosmic time and let's convert it to years and days. If you take 16 billion years and divide it by a million, what you'll get is 0.016 years. Converted to days, 0.016 years comes out to be 5.84 days. Pretty close to 6 days, isn't it, when you're dealing with the estimates in first of when did Big Bang occur and what was the initial value of Big Bang. Okay, just again, kind of another time check between Genesis and science. So, did the creation of the universe take 6 days or 16 billion years, plus or minus a few billion? The answer is yes. Okay? It depends on which reference frame the timekeeper is in. If you were in the cosmos, the 16 billion years could very well, I'm not saying it was, but I'm saying the math shows it could be very close, almost exactly 6 Earth days, okay? By the time of Adam, again, 5,770 years ago, the two clocks had pretty well merged, that decaying exponential. The mathematician would say it becomes asymptotic to the x-axis. Doesn't mean hoopy-doo. It just means it decreased till it almost became that value, but not quite. Okay. Conclusion, both Genesis and science are describing, my conclusion now, are describing the same creation. The two clocks are in two different reference frames. The cosmic measure of time, by the time you convert it, correlates very closely with Genesis time. The stage, more importantly to me, the stages of creation, what happened during each of those days, agrees almost perfectly between what astrophysicists say and what Genesis says. This is purely for your amusement, and I know, Bob, you and I have talked about this. A calculation by, is that Ushers? Is that the way you pronounce his name? So anyway, USSHERS. Once asserted that creation took place, now this is ridiculous, at nightfall on October the 23rd, 4004 BC. This was actually printed in the King James Version of the Bible until the early 1900s. Okay? Just for your amusement. Here's just my interpretation. I believe that the way we started this presentation out, that the Bible and physics are coming closer and closer together. This quote here from Gerald Schroeder. It's remarkable that the theistic description of creation so closely matches the perception of current cosmology and paleontology. Listen now. Theology did not respond to science. Through its progressively improved understanding of the world, science has come to agree with theology. Okay? Let's now look at some other, do I have a little more time? Okay, thank you, I'll try to hurry. Let's look at some other fascinating parallels, and I'm going to try to get through this. I'm going to play what science says and the Bible says, kind of whatever you call that game. Prior to Big Bang, time did not exist. Both Maimonides and Nachmanides commented on Genesis, written about 1200 A.D., and there was evening and there was morning and so forth. Hebrew did not say the first day. It used the cardinal, not the ordinal. It did not say first day. It said day one. St. Augustine, again, asserted the universe was created with time, not in time. Science says at Big Bang the elements came into being that would be necessary to form the hydrogen and helium. I'm probably going to have to stop here and start over. You wanted to allow, I believe, some time for questions, did you? I'm sorry, I thought you were giving me a signal. Okay, let's go. Just tell me to shut up or pull the plug whenever you want to. At Big Bang, the elements came into being that would be necessary to form hydrogen and helium. Remember, the temperature was so great that even quarks, the atomic particle below protons, electrons, and neutrons, could not even form. The only thing that could form then were the lighter elements, hydrogen and helium and a little bit of lithium. The problem was that to create the heavier atoms, elements if you will, required temperatures that could only be found in exploding stars. So that occurred. The other elements were formed literally hundreds of millions of years after hydrogen, helium, and lithium were formed. Let's look at what the Bible says. I'm going to do some Family Feud stuff. And the earth was without form, Hebrew word tohu, and void, bohu. Bohu, the Hebrew, means void, but containing the materials needed to make other things. What does science say? Created the elementary particles much below the atomic level. But from that, when the universe cooled, the other elements, even protons, electrons, and neutrons appeared. By the way, this is the only place in Genesis 1 where God used the word created, or Moses did. Everything else was made. Created means ex nihilo, or from nothing. Okay. Science says, Einstein showed that space comes from nothing. Remember the rumblings in the vacuum? At that time, space, matter, and time were created. Einstein showed that energy comes from space, matter comes from energy. Remember probably the most famous equation, E equals mc squared? What Einstein said is energy is matter. The proportionality constant is simply the square of the speed of light, c. The Bible says, again, Maimonides and Maimonides, if I say them correctly, discuss the duality of energy and matter. Remember, this was 4,000 years before Einstein came up with E equals mc squared. Okay, so it's kind of... universe began with a quantum fluctuation. We've been through this. I'm going to go back. It was made up of what we now call TOHU and BOHU. It was 10 million billion times the temperature of the sun. Quark confinement occurred, and then the universe started cooling. Maimonides, about 1200, said, at the briefest instant following creation, all the matter of the universe was concentrated in a very small place, no larger than a grain of mustard. It expanded and then became, obviously, what you see now. Everything that has existed or will ever exist was, is, and will be formed. That's Genesis 1 and 2. Science says the leading particle physicists now refer to T and B. Remember Tohu and Bohu, the Hebrew words, are the two basic building blocks of all matter. Now this is science has now taken the Hebrew word out of Genesis, and they are now referring to the elementary particles as T and B, Tohu and Bohu. And the earth was without form, Tohu and void, Bohu. Tohu literally means the solitary primordial substance created at beginning. Remember, this is not an electron or proton or neutron. It's the high energy particles that were created, the really energy. Bohu literally means in it, bo meaning in it, hu meaning there is potential. In other words, what was created were the particles that had the potential to become electrons, protons, neutrons, then they combined and formed matter. Science says it took the alchemy of the cosmos to convert the primordial hydrogen and helium into the rest of the elements. The only place you can find temperatures high enough to fuse hydrogen into helium and so forth is in exploding stars. Therefore, the explosion and rebirth of stars are where the heavier elements came from. By the way, you have hydrogen, helium, lithium, and then you get to carbon, which life on Earth is carbon-based. Chemists will tell you there is no natural reason why that fusion should occur to form carbon, but it does. The temperatures required to fuse the lighter elements into heavier elements can only be found in exploding stars. Stars are thermonuclear fusion reactors, not fission. The atomic bomb was a fission bomb. The energy came from splitting the atom. The nuclear bomb is a fusion bomb. It comes from forcing two units. It's a shotgun wedding. It comes from forcing two unwilling elements together to form a third element. By the way, our sun fuses 400 million tons of hydrogen into helium every second. The bomb dropped on Hiroshima was 1 kilogram, roughly half a pound. It was the 1 kilogram fusion of hydrogen, 1 kilogram. Now remember, the sun does 400 million tons a second. It's 15 times the power of Hiroshima bomb. In 1 second, the 400 million tons of hydrogen the sun is fusing is 6.6 trillion times the energy released at Hiroshima. That occurs and has been forever. We humans and everything in it are basically stardust. At about one millionth of a second after Big Bang, the universe was the size of a speck of dust. It would have to be studied by a microscope. Now, 15, 16 billion years later, we can't even study it all by the most powerful telescopes. So to give you an idea. Science says there was a period called inflation right after Big Bang where the universe, an outward force, pushed the universe to expand very rapidly. Why? The size went from a speck to the size of our solar system. It was needed and occurred. Now, science calls that the inflationary period. What does the Bible say? Genesis 1 and 2. And the earth was without form and void, and darkness was on the face of the earth, and God's wind stirred on the face of the waters. I'm going to skip a little bit of it here. It's not like the wind of Exodus. This is the only place that it's used. And the Bible is describing what scientists describe as the inflationary period of the cosmos. Also, until 1992, scientists discovered something called dark energy. It's a force, we don't know what it is, that's pushing the universe to expand now at the speed of light. Dark energy is what it's called, and it comprises 75% of the universe. The universe we see is 4% of the mass of the universe. Dark energy is 74 to 75%. Dark matter, I think I done messed up. Sorry. Well, I done messed it up here now. Hang on a minute. I'm going to go to this one. Nothing can be known, science says nothing can be known about the pre-singularity. In other words, time didn't exist before Big Bang. The Bible says the King James Version, by the way, is the first translation that begins Genesis 1 with "in the beginning." Before that, all previous translation began with first wisdom. The shape of the first letter in the original Hebrew, the word is Bereshit, is only open in the forward direction, which means anything before is unattainable. The word itself is a compound word, be meaning with, and Bereshit meaning first wisdom. That's the way until the King James Version began. I just quote two verses there, the last one being Psalms 104, how manifold are your words, eternal. Science says an object can be more than one place at the same time. This is Heisenberg's uncertainty principle. Quantum entanglement allows this. The Bible says, Philip was sent by an angel to explain the gospel to an Ethiopian eunuch in Gaza, then immediately appeared in Azotus or whatever it is. In other words, the Bible talks about instant teleportation. Science says elapsed time is seen by an observer is dependent upon the reference frame. Well, have you ever heard this? For 1,000 years in thy sight, but as yesterday when it is past, and as a watch in the night. Remember, God's not in the same reference frame as are we. He's outside of the universe frame of reference. No gravity means zero elapsed time. Therefore, the past is the same as the present, is the same as the future, which is now. Biblical theory of relativity. This particular quote that I just went through, or the Bible quote, is often referred to as the first written reference to special relativity. Now remember, this was written in Genesis. Einstein came upon it in 1903. Okay, I think I've wound down for tonight. I appreciate you bearing with me. I know I've gone over time. I'm supposed to do we still have time for questions if anyone wants some? Thank you very much for your attention.
I don't see any questions right now.
Okay. Well, thank you very much. Next time we're going to go over further observations on Genesis and science. We're kind of through with creation right now as far as my comparison of the two. Okay, thank you very much for your attention. Hopefully see you next Wednesday.